Have you ever stared up at the night sky, seen thousands of stars twinkling above you, and wondered, just how big is the universe, really? It's a question that has fascinated humans for thousands of years, from ancient philosophers who believed the stars were tiny holes in a celestial sphere, to modern cosmologists armed with powerful telescopes that can peer back billions of years into the past. Today, thanks to astronomy, physics, and advanced space exploration, we know more about the size of the universe than ever before. But the answers we've found are both awe-inspiring and deeply humbling. The universe is not just big, it's almost unimaginably vast, stretching across distances and timescales that challenge the limits of human comprehension. In this video, we're going to take you on a journey from the familiar scale of our Earth and solar system, out past the stars of the Milky Way, across cosmic filaments of galaxies, and into the furthest reaches of the observable universe. Along the way, we'll uncover how scientists measure these vast distances, what we know about the universe's ultimate size, and why the cosmos might be far bigger and stranger than we can possibly imagine. So buckle up, because this journey is going to take us to the very edge of space and time itself. Let's begin where we are right now, on Earth. Our planet has a diameter of about 12,742 kilometers. That sounds large until you compare it with our nearest celestial neighbor, the Moon, which orbits us at an average distance of 384,000 kilometers away. Now, if we zoom out to include the Sun, things already start to get mind-bending. The Sun is about 1.39 million kilometers across, over 100 times larger than Earth. And yet, despite its immensity, it is just an average star among the hundreds of billions scattered across our galaxy. The Earth orbits the Sun at a distance of 150 million kilometers. A distance so vast that light itself, which travels at 300,000 kilometers per second, takes 8 minutes and 20 seconds to get from the Sun to us. That unit of measurement is known as an astronomical unit, AU, and astronomers use it as a basic yardstick for measuring distances within our solar system. The solar system is much larger than many people imagine. Beyond Earth, we have the gas giants like Jupiter and Saturn, which are many times larger than our planet. Saturn's rings alone stretch across 282,000 kilometers, wider than the distance from Earth to the Moon. But the true scale of the solar system becomes clear when we travel further out. Neptune, the most distant planet, is about 30 from the Sun. That means sunlight takes more than 4 hours to reach it. Yet even that isn't the true edge. Beyond Neptune lies the Kuiper Belt, home to icy worlds like Pluto, and further still, the hypothetical Oort cloud, a shell of comets that may extend up to 100,000 from the Sun, about 1.5 light-years away. So just our solar system alone stretches across distances that defy imagination. And yet, compared to the galaxy, it's less than a grain of sand on a cosmic beach. Now let's take another leap outward. The Sun is just one star among an estimated 100 to 400 billion stars in the Milky Way Galaxy. Our galaxy is a vast rotating disk about 100,000 light-years across. To put that in perspective, a single light-year is the distance light travels in 1 year, about 9.46 trillion kilometers. So the Milky Way's span is on the order of 946 quadrillion kilometers. If a spaceship could travel at the speed of light, it would still take 100,000 years to cross the Milky Way from one side to the other. And that's just our local island in the cosmic ocean. Within the Milky Way, stars are not evenly spread out. They cluster into spiral arms, with dense regions of stars, gas, and dust. Our Sun is located in a relatively quiet neighborhood, about 27,000 light-years from the galactic center. But the Milky Way isn't alone. It's part of a local group of more than 50 galaxies, dominated by two giants, the Milky Way and the Andromeda Galaxy, which is about 2.5 million light-years away. Andromeda itself is even larger than the Milky Way, stretching about 220,000 light-years across, and the two galaxies are on a collision course, expected to merge in about 4 to 5 billion years. As we zoom further out, galaxies themselves gather into clusters. The Milky Way and Andromeda belong to the local group, which spans about 10 million light-years. But the local group is only a small part of the Virgo supercluster, which stretches across 110 million light-years. And even that is just a piece of an even larger structure known as Laniakea, a supercluster spanning 520 million light-years and containing over 100,000 galaxies. At this scale, galaxies look like tiny specks forming vast cosmic webs, filaments and walls of galaxies separated by immense voids. These patterns resemble a three-dimensional cosmic sponge, with matter concentrated along filaments and enormous empty regions spanning hundreds of millions of light-years. Now let's talk about the ultimate limit, the observable universe. Because light travels at a finite speed, when we look far away, we're also looking back in time. The furthest we can see is the light that has had enough time to reach us since the universe began. According to current cosmology, the universe is about 13.8 billion years old. That means the farthest light we can see comes from just after the Big Bang. But here's the twist. Due to the expansion of space, those distant galaxies are now much farther away than 13.8 billion light-years. The actual radius of the observable universe is about 446.5 billion light-years in every direction. That gives us a diameter of roughly 93 billion light-years. Within this sphere lies everything we can possibly observe, about 2 trillion galaxies, each with billions or trillions of stars. And remember, this is just the observable universe. The actual universe could be much larger, perhaps infinitely large. You might be wondering, how do scientists even measure these enormous distances? The answer lies in clever methods known as the cosmic distance ladder. 1. Parallax. For nearby stars, we measure the tiny shifts in their position against the background as Earth orbits the Sun. 2. Standard candles. Objects like Cepheid variable stars and Type 1a supernovae have predictable brightness, allowing astronomers to calculate their distance based on how dim they appear. 3. Redshift. For galaxies billions of light-years away, we use the stretching of their light due to the expansion of the universe. The further away a galaxy is, the more its light is shifted toward the red end of the spectrum. Combining these methods, astronomers can measure distances across billions of light-years with remarkable accuracy. Here's where things get truly mind-bending. The observable universe is limited by the speed of light and the age of the cosmos, but the universe itself doesn't stop there. Most cosmologists believe the universe extends far beyond what we can see. Some theories suggest it could be hundreds of times larger than the observable portion. Others propose it might be infinite. And then there's the idea of the multiverse, that our universe might be just one bubble among countless others, each with its own laws of physics, dimensions, and possibilities. While still speculative, these ideas arise naturally from certain interpretations of inflation theory and string theory. One of the most astonishing discoveries of the 20th century is that the universe is not static, it's expanding. In the 1920s, Edwin Hubble observed that distant galaxies are moving away from us, and the farther they are, the faster they recede. This led to the concept of the Big Bang, the moment about 13.8 billion years ago, when the universe began expanding from an incredibly hot and dense state. Even more surprising is that the expansion is accelerating due to a mysterious force called dark energy. Right now, about 70% of the universe is made of dark energy, 25% is dark matter, and only about 5% is normal matter, the stuff that makes up stars, planets, and us. This means that over time, galaxies outside our local group will recede faster and faster until they disappear beyond the cosmic horizon. In the far future, the observable universe will shrink to just our local cluster of galaxies, while the rest of the cosmos drifts forever out of reach. So how big is the universe, really? The short answer? The observable universe is about 93 billion light-years across, containing trillions of galaxies and likely sextillions of stars. But the true universe may be vastly larger, possibly infinite. Every step outward we take, from Earth to the solar system to the galaxy to superclusters, and then to the cosmic web, shows us just how tiny we are in comparison. And yet, in this immensity, we are also incredibly lucky to exist at all, and to have the tools and curiosity to even begin answering these questions. When you stand outside on a clear night and look up at the stars, remember, you're seeing just the tiniest fraction of what's out there. The light reaching your eyes has traveled across unimaginable distances, some of it from stars long dead, some from galaxies on the edge of the visible universe. The universe is not just big, it's beyond comprehension. And yet we humans on our small blue planet have found a way to measure, map, and understand this cosmic immensity. So the next time you look up at the night sky, take a moment to appreciate the incredible fact that you are part of this vast universe. A universe that may be infinite, eternal, and full of mysteries still waiting to be uncovered. Thanks for watching. If you enjoyed this journey through space, don't forget to like, share, and subscribe to Amazing World Facts for more videos that explore the wonders of our universe. And let us know in the comments, what do you think lies beyond the observable universe?